All right, I'm making the review for trig test video. Now I'm doing it with all my noises in my house, so enjoy. All right, so sine squared plus cosine squared x. Anytime you see a squared, it's a good idea to think of the Pythagorean identity, and sine squared plus cosine squared is 1 over cosine of x. The reciprocal of cosine is secant. Next. Okay, and again, I'm just doing these on the fly, so if I get them wrong, sorry. Okay, next one. Sine squared b over cosine of b plus cosine of b. Now this is addition. So remember, we can't cross out through addition. If we have to add, we have to find common denominators. So this one has a cosine of b, so this one needs a cosine of b. So we wind up getting sine squared plus cosine squared over cosine. And we just did this. This is the exact same problem then. But the answer is sine squared plus cosine squared is 1. And then this is cosine of b. So this is 1 over cosine of b. So that's secant. But that isn't one of the answers. So it has to be this one. All right, this one here. Secant of theta. So secant of theta, I remember one of your first steps is always get terms of sine and cosine. So secant is 1 over cosine. Tangent is sine over cosine. I know the desire is to make it 1 over cotangent or something, but you don't want to do that. Put in terms of sine and cosine. So remember, this is a giant division sign, so it's like a division sign going down. So remember, it's keep. Change to multiplication, and then flip this guy. So it's 1 over cosine, this is an equals, 1 over cosine times cosine over sine. These cancel out, so it's 1 over sine, that's not an option, and 1 over sine is cosecant. Next. I don't know, does that go up here? Where's the next one? Nope. Sorry. Awesome. Anyway, sorry if I made you dizzy. Number 4. Okay, put in terms of sine and cosine if you can't think of anything else. There's my son coughing. Okay, now it's always a good idea if you have a fraction to make them all fractions, otherwise sometimes you forget. So now we distribute to both. So this becomes, remember the cosine goes on the top, so it's cosine over cosine minus, this is cosine times cosine, which is cosine squared, and 1 times 1 is 1. Yes? Sorry, I'm just looking at it. Oh, yeah, duh. Okay, so cosine over cosine is 1, and 1 minus cosine squared is your Pythagorean identity, sine squared. Done. Next. All right, number 5. All right, we did this one in class, actually. You don't have... you remember the Pythagorean identity, it has to be a squared. So 1 minus cosine squared is equal to sine squared. But that doesn't help you here because this isn't squared. So you have to do the math. So either do the box or double distribute, whatever you desire. Okay, so it's 1 minus cosine x plus cosine x, and then this is minus cosine squared x. These cancel out, and you're left with 1 minus cosine squared x, which, as we just discussed, is sine squared x. Okay, terminal side of an angle in standard position lies in quadrant 3. This angle could be. So which one of these is in quadrant 3? I'm going to go with this one. You can just graph each one of them. Well, I guess I could do each one of them like, excuse me, like this. So 120, this is 90, this is 120. Okay, remember this is 180, 90, 270, and 0 or 360. So over here, A, negative 255, so negative goes down, so this is negative 90. This is negative 180, negative 270 goes all the way, so this would stay in quadrant 2. Same with this one. This is going down because it's negative, so negative 90, negative 180, negative 270 would be here, so we don't go that far. Okay, the only other option is this one, negative 110, negative 90, all the way to here would be 180, so it's got to be somewhere in between here. So it's got to be this one. Okay, number 7. Okay, so we want a quadrant 4 angle. So we should convert each one of these 2 degrees. I need to get my calculator. Oh, here it is. Okay. So we want it to be in quadrant 4. Okay, so convert each one of these. Remember to convert 2 degrees, it's 180 over pi. So we're going to do that to each one of these. Okay, these pi's cross out, and then we just do the math. This is 3. This is, you can just, I'll put it in your calculator. Since I'm sitting here, I'm going to do it like this. So negative 120, well, we just did that. That was like negative 110. It's in quadrant 3. Oh, yeah, quadrant 3. B, this cancels out. 180 divided by 4 is 45. So 3 times 45 is 135. That's quadrant 2. Continuing on, this is 60 again. Negative 7 times 60, negative 420. 420. So if I add 360 to that, it gets to be negative 60. That's in quadrant 4. Okay, negative 60, remember going down is negative. This is negative 90. This is 0. So then this around here somewhere would be negative 60. Don't even have to figure out this one. All right, next. Number 8. What's the following coterminal? Remember 915, when you're talking coterminal, it means you go around in a full circle and it's still in the same spot. So that means you either add 360 or subtract 360 to get there. So 915 minus 360 is 555. That's not there. Do it again. Minus 360, I get positive 195, and that's there. There you go. So add or subtract 360 to find another coterminal angle. Page 2. Which of the following angles is coterminal? Same deal. This is a negative 557. So I have to add 360 to get to be positive. Negative 197. That is not positive 197. So I'll do it again, add 360 again. And I get 163. There we go. Okay, 600 converted to radians in terms of pi. 600 times pi over 180. Remember, we could just put this in our calculator. Put 600 over 180 in your calculator, either as a fraction or as a decimal, and you get 10 over 3. Remember, but this pi is here, so it's 10 pi over 3. Next. What is 162 to convert it to radian measure to the nearest hundredth? So it's the same question. But this time, we just plug it all in our calculator exactly the way it is right here. So it's 162 times pi divided by 180, and to the nearest hundredth, so it's 2.8274, blah, blah, blah. So the nearest hundredth, remember hundredth, two zeros, so it's 2 decimal places, 2.83. Next. Okay, 10 pi in degrees. So 10 pi in degrees, multiply times 180 over pi. These cancel out. 1800. Next, goes up. Okay, in degrees, so negative 11 pi over 6. Now, just right off the bat, this is negative, so the answer should be negative, so this guy is gone. Just to see that from the start. But then this is 180 over pi. These cancel out. This is 6 goes into 6 once and into 80 30 times. So 11 times 30 is negative 330. Number 14. Negative 1.5. We want to express this to the nearest degree. So remember, it's always 180 over pi. I know there's no pi in this one, but it doesn't matter. Plug it in your calculator. Negative 1.5 times 180 divided by pi. Divided by pi. Negative 85.94. 366, whatever. So 85.9. Negative 85.9. Done. Yeah, so this was a negative, so these guys wouldn't be an answer anyway. Okay, so just be careful of that. All right. So in the accompanying diagram, what point is that? That's interesting. Okay. Okay, well this one, I don't know if we really went over this stuff, but you know that x is cosine and y is sine. So you know that the cosine of is theta is equal to negative 0.6. I know how to do this. I'm just debating how to explain this to you. So negative 0.6, you have to hit the second button in your, so you have to do the cosine inverse in here. Yeah, there's nothing like this is going to be on the test, so let me just give you the answer so that you have it. So, sorry, it's 53 plus 180, 233. Okay, probably the best way for you guys to do it would be just to do the cosine of 217 and see what that is. Do the cosine of 233, see what that is. Cosine of 225 and the cosine of 143. Or the sine, but the sine you would be using that. And see which one comes closest. That would be the best idea for you guys. Okay, so cosine of 233 is negative 0.6018, whatever. So there you go. That's the answer. All right, that was 15. Nothing after. Okay, 16. Okay, what's the coordinates of, if the length of OP is 1, so this means this is a unit, you know, if we drew a circle, it would be a unit circle. So what are the coordinates of P? It's cosine, sine. There you go. It's just what it is. Okay. So this is a unit circle. You know negative radical 3 over 2, negative 1/2. Remember, this is cosine. Oops, sorry. Cosine of x. This one is the sine of x. So you have to know your exact values. So you know it's negative. So you do know it's in quadrant. Both of them are negative, so you know it has to be in quadrant 3. So all of these angles are in quadrant 3. And what angle has a cosine of radical 3 over 2? Oh, sorry. Is 30. So this, you know that this reference angle here is 30 degrees. So you add 180 plus 30 is 210. Yeah. Sorry. Sometimes I have to think a little harder than most. Okay, over here, if this is 30 degrees, right here, so you'd have to know the cosine of x, or of 30 degrees, I guess, comma the sine of 30 degrees. So what is the cosine of 30 degrees? We just did that. It's radical 3 over 2. What's the sine of 30 degrees? That's a half. So radical 3 over 2 and a half. There we go. So you have to memorize those. There's really no other way. Some sort of memorization has to take place. Whether it's you remember what it looks like in the calculator or whatever, you have to memorize. So P 0, negative 1 is down here. Terminal side angle and angle standard position. What is the exact value of cotangent? So you know that cotangent of theta is equal to cosine over cosine of theta over sine theta. So remember, this is x, this is y. Cosine is x, sine is y. So it's 0 over negative 1, which is 0. Cotangent, it's cosine of, yeah. Okay. So when they're asking what quadrant does the angle terminate, all you really have to look at is if those guys are positive or negative. So we just look at our ASTC. So what quadrant does it terminate? We don't really care about what the value of the angles are. So sine is negative, so you know sine is positive up here. So we get rid of those. And cosine is also negative. Remember, less than 0 means negative. So it couldn't be there also. It's got to be in quadrant 3. 21. Okay, now they're telling you this angle lies in the second quadrant. So you know you're here. So sine is positive, but you know that the answer is going to be negative because this is cosine. They're asking what cosine is. So you know cosine is negative. It's got to be one of these two. Okay. Tangent is 2 over 3. So if tangent is 2 over 3, remember tangent is opposite over adjacent. Now we dealt with the sine already. We don't have to worry that it's negative. That only deals with what quadrant we're in. So if this is theta, tangent is opposite over adjacent. So Pythagorean Theorem, 2 squared plus 3 squared equals the hypotenuse. So 4 plus 9 is 13. Square root. So x is radical 13. So if I want to know cosine, cosine is adjacent over hypotenuse. So you know adjacent is 3, hypotenuse is radical 13. Oh, none of those answers are there. Okay, that means we have to rationalize. So it's 3 radical 13 over that. So it's 3 radical 13 over 13. And we know it's negative because we're in quadrant, second quadrant. So here we are. That was a mess. Next, 22. What is the reference angle for that? So we do have to convert that first. So 14 pi over 3 times 180 over pi. The pi's cancel out. This is 60. 14 times 60. 840. Okay, so remember the steps for finding the reference angle. We want an angle between 0 and 360 first. So this is not between the 0 and 360, so we have to do the coterminal thing. So subtract 360. $480, still not between 0 and 360. Subtract 360 again, you get 120. Sorry, down here it was 120. Okay, so we want the reference angle for 120. So when we draw 120, it looks like this. Okay, so remember, reference angles always form with the terminal side and the x-axis, the nearest x-axis. So remember, this nearest x-axis is 180 degrees. So we do 180 minus 120, and I get 60. Okay, if you remember. If you remember, that 60 is pi over 3. That's great. Otherwise, you convert times pi over 180, and you do the math. Just to be clear here, this kind of problem, when you're finding a reference angle, remember reference angles do have to be positive and acute. So if you don't really know what this one is, you should, figure that out. But they always have to be positive and acute. So these two are gone just to begin with. All right, next, 23, reference angle of 230. Again, same basic process. I know these two can't be it because it has to be between a positive acute angle. So it can't be negative. These two are gone. So it only can be 50 or 30. So we look at 230. When I actually sketch 230, it looks something like this. Okay, it's in quadrant 3, so we have to back it up. Okay, it's always the terminal side and the x-axis. So you back it up, cut off that 180 degrees, so it's 230 minus 180, 50. Okay, use the information marked on the figure to find the value of x and y. Okay, so we have our special right triangles here. So you have to remember the special right triangle ratio. This is a 30, 60, 90. So 30. Across from the 30 is 1. Across from the 60 is radical 3. And across from the right angle is 2. That's your ratio. So we just put x. Oh, well, I guess I shouldn't put x's on there. Hold on. No one likes the x's, so let's put a's. Okay. So that we know that the side opposite the right angle is 16, so that's this one. So 2a equals 16. So we just figure out what a is. A is 8, and we can find the other two sides. So this one here is radical 3a. So, we didn't just do that. Okay, it's radical 3a. So we just plug in 8. And we usually write it like this. 8 radical 3 is your y. Okay, now x. X is 1a. So we just, again, plug in 1 times 8 is just 8. So that's what x is. Done. Okay, same deal for this one. Okay, this time it's across from the 60-degree angle. So remember, it's 1a, radical 3a, and 2a. So across from the 60 is this one. So radical 3 times a, remember this is not under the radical, equals 15. So we divide by radical 3, and that tells you what a is. Rationalize. Okay, when you rationalize, it's 15 radical 3 over 3. This cancels with this one. 3 goes into 3 once. 3 goes into 15 5 times. So 5 radical 3 is what your a is. So then you just plug in a for the other two. So x is 1a. So we just do 1 times 5 radical 3, which just makes x. 5 radical 3. Okay, and then we do the same thing for this one. Y is 2 times a, so it's 2 times 5 radical 3, so it's 10 radical 3. All right, awesome. Any more here? Oh, all right, so we still have to do one with the 45, 45, 90 right triangle. Remember that ratio is 1a, 1a, radical 2a. Remember that a is not under the radical. It's just keeping it the same here. Okay, so across from the right angle here, we get 12 radical 2. We know the ratio is radical 2a, so divide by radical 2. We get 12. A is 12. Okay, so since a is 12, each one of these is 1a, so if you plug in 12 there, you get 12. So each one of these sides is 12. All right, one more, 45, 45. Oh, I have to do it with a. All right, then. I'll use a different letter then. So let's do 1b. 1b, it's radical 2b. So just because this letter is already a, I don't want to reuse it. Okay, so they're telling you what the side opposite the right angle is. So that's radical 2 times b is your a. Okay, so is a. So this thing right here, this number that you multiply by, is what you need to solve for. So it's b is equal to a over radical 2. Rationalize this guy. So it's a radical 2 over 2. And so each one of the other sides, we just plug in radical 2 over 2. Oh, a radical 2 over 2, excuse me, in this spot. And that's what each one of the sides are. That's an interesting question. Okay. All right, I guess that's that for that side. Okay, number 6. Sketch in the standard position and state the quadrant. Oh, hey, where'd you go? State the quadrant in which the terminal side lies. Okay, I can do that. Okay, 220. So remember, when we're doing this positive, we start here and we go up. So remember, this is going to be 90, 180, 220 is somewhere in here. Doesn't have to be perfect, but you do need the arrow here. Label 220, and this is quadrant 3. This one here, negative 340. Okay, so remember with negative angles, we start here and go down. So this is negative 90, negative 180, negative 270, all the way down would be negative 360. So we don't want to go that far, but close. So this is negative 340 degrees, the whole thing. And it's in quadrant 1. Oop, I just kept going with that. It's in quadrant 1. Okay, this one, sketch the angle in standard position, then sketch its reference angle and label it as alpha, and determine the measure of the reference angle. Okay, so there's a few things you have to do here. Things that are going to make it a little bit easier is if I actually know what degrees are in this. So I'm going to multiply this times 180 over pi, reduce this out. So 5 times 180 divided by 4 is negative 225. All right, so I need to sketch this guy first. Sketch the angle in standard position. So negative 225, same basic idea. We have to go down. Start here and go down. Negative 90, negative 180. All the way up to the y-axis here would be 270. So it doesn't go that far, but it goes almost, you know, that looks good. So that's sketching in standard position. Make sure you have that arrow. Definitely need that arrow there to show that we're measuring this way. So that's negative 225. Should label it. All right, the reference angle. Remember, the reference angle always goes from the terminal side to the x-axis. So it's this, how many degrees would be in here. Okay, remember, reference angles are always positive and acute. So this is your alpha, and they actually want the measure. So the measure of this would be negative 225 plus 180. So that's negative 45. I know that's not wonderful, so this should be positive 45. Okay, this is positive 45 degrees, and that's great and all, but the question was asked in radians, so the answer needs to be in radians. So you need to convert this back. 45 times pi over 180, and when all is said and done, it's pi over 4. Okay? As a function of a positive acute angle. So whenever you want to express anything in terms of a positive acute angle, they're saying, okay, I want the reference angle there. So we just do the box line box. Okay, this goes here. Sine. Okay, remember the questions you ask yourself. What quadrant am I in? So 186. This whole, all the way to there is 180, so 186 would be right here. So I'm in quadrant 3. Sine is positive in quadrants 1 and 2, so in quadrant 3 it's going to be negative. Then we do the reference angle. The reference angle is the angle formed by the terminal side and the x-axis. So we just cut out the 180, and I get 6. Okay, 510. All right, same idea. Box, line, box. So we're going to put cosine here. So we have to figure out what quadrant 510 is in. So remember, we do need a coterminal angle between 0 and 360. So subtract 360 and I get 150. So 150 is over here in quadrant 2. So remember, cosine is only positive here and here. In quadrant 2, cosine is negative. And then we need the positive acute angle, which again is its reference angle, so we'll use 150. So we do 180 minus 150, which is 30. So it's negative the cosine of 30. Okay, same idea. Box, line, box. It's cosecant. 264. Remember, well, let's do 264 first. So this is 90, 180. 270 would be all the way to there, so it gets close, but it's still in quadrant 3. Okay, cosecant is the reciprocal of sine. So sine is positive here and here, so this guy is going to be negative in quadrant 3. So we do 264 to find the reference angle. We subtract 180. 264 minus 180, 84. Positive acute angle, so it's negative cosecant of 84. Okay, exact value of tangent, negative 240. So for exact value, we have to do the box, line, box thing. So it's tangent. So negative 240, we want an angle. So negative 240 would be here. 180, 270 would all be up here. So 240 is in quadrant 2. So tangent is negative here. Tangent is positive, negative, positive, negative. Okay, so it's negative in quadrant 2. To find the reference angle, I did it a different way the last time, so I'll just, best way to do it is get an angle between 0 and 360 first. So it's negative 240 plus 360 is 120. So 120 is coterminal with that, so the reference angle would be an angle formed by the terminal side and the x-axis, so it's 180 minus 120, which is 60. 60 is the reference angle. So this is negative the tangent of 60, so it's negative, and the tangent of 60 is radical 3. So it's negative radical 3. A lot of work for one problem, but it's all good. Okay, find the exact value of secant 3 pi over 4. So we have to do the same basic thing, but 3 pi over 4 we should convert first. Oops, so 3 pi over 4 times 180 over pi. So 3 times 180. So it's 135. Okay, 135 is in quadrant 2. Secant is the reciprocal of cosine. So the reciprocal of cosine would be negative in quadrant 2. So it's negative the secant of, and then we have to figure out a reference angle. So the reference angle of 135, it's in quadrant 2, so it's 180 minus 135. So that's 45, so it's negative the secant of 45. You could do that with a right triangle. You could do that the reciprocal of cosine of 45. It doesn't really matter. So you can do, it's the same as 1 over negative cosine of 45. So it'd be, you flip the cosine of 45. So since the cosine of 45 is radical 2 over 2, you flip it, it'd be negative 2 over radical 2, and then rationalize. The 2's cancel out, and we are just left with negative radical 2. Exact value of this one, same basic idea. 2 pi over 3, convert that. These cancel. This is 60, so it's 120. Again, do it your own way. I'm just kind of doing it to get it done. So cosecant 120. Cosecant is a reciprocal of sine. Sine is positive in the first 2 quadrant. 120 is in quadrant 2. So this guy is going to be positive. Positive 120. Reference angle here is 60. So it's 1 over the sine of 60, which is 1 over the sine of 60 is radical 3 over 2. So this just simply says change this to multiplication and then flip. Again, remember this is just a division problem. Okay, so it just means flip this. So it's 2 over radical 3. Rationalize to radical 3 over 3. And it's positive because we are in quadrant 2. Find all the values of theta that satisfy the condition sine theta equals 0. Okay, easiest route to take with this one, and it's just the way I do it, is using the unit circle. So remember, if I draw, awesome unit circle. I'm sure they have a shape here I could probably use. Hold on. Hold on, I need a circle. So, okay, so there's a circle. Awesome. Okay, so right here, whatever. Right here, the quadrants are the coordinates are 1, 0. Up here, if this is the unit circle, it is 0, 1. This one is negative 1, 0. And this is 0, negative 1. So where all the values that satisfy sine theta equals 0. So remember, sine is y. So where are the y values? 0. So here's a y value that's 0, and here's a y value that's 0. Y is -1 here, 1 here. So it's this angle here is 0 or 360, but they don't have an underline here. So 360 isn't an answer. And then over here, it's 180. So the two values are 0 and 180. So 37, 38. Same question for cosine. Wish I could reuse that picture. So let's just write the points here. So it's 1, 0, 0, 1, -1, 0, and 0, -1. So where is the cosine 0? Remember, cosine is x. So where are the x values? 0. So here it's 1, here it's 0, here it's -1, and here it's 0. So cosine is 0 at 90 degrees, and down here at 270. Oop. Okay, I need to just take, can I take this picture? Okay, the same idea here. All the values where sine is -1. So 1, 0, 0, 1. It actually is a good idea to keep doing this. You get practice and you'll memorize them better. So where is sine -1? Where is the y value -1? Here the y value is 0. Here it's 1. Here it's 0. Here it's -1. So only at 270. Same question with cosine. We need those 4 points. 1, 0, 0. I'm getting good at this. -1, 0. Yeah, almost. 0, -1. Where is cosine -1? So where are the x values -1? So here x is 1. Here it's 0. Here it's -1. And here it's 0. So it's at this angle, which is 180. See how I did that? 180 degrees. Next. Okay, for this guy right here, the point radical 3/2, 1/2 is on the terminal side of an angle in standard position. If the distance of the point from the origin is 1, find sine and cosine. Okay, distance from the origin is 1. That's saying this is the unit circle. Hear my son coughing. Hey, poor boy. Okay, so sine of theta. Remember, this is x, this is y. Sine of theta is your y. So it's 1/2. X is your cosine of theta. So it's radical 3/2. That's as easy as that. And you could even tell us the angle if you wanted to. Where's cosine? Radical 3/2. They're both positive, so it's got to be quadrant 1. Radical 3/2 for cosine is what, 30? So that's not the answer. I'm just embellishing. Okay, if -1, -1 is a point on the terminal side of an angle in standard position, evaluate all 6 trig functions. Okay, all right, so, thought I was drawing. So -1, -1. So that would be right here. This is -1. This is -1. Okay, remember we always drop to the x-axis. So we draw this triangle here, and theta is always with the x-axis. So it's the hypotenuse and the x-axis that forms your theta. Okay, all 6 trig functions. So we're in quadrant 3. So I just do this. Sine, cosine, tangent. Cosecant is the reciprocal. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So if I'm in quadrant 3 here, I'm just going to do my signs first. So these are negative, and these are positive. Okay, so then because of this, I can just forget about these little signs. I won't let me erase. I guess I could probably draw in white. Hold on. Oh, look at it. So I can forget about those signs. We can look at the right triangle here, and we're good. So let's look at this right triangle. So we have 1, 1, and then this one side. Hopefully you realize that this is a 45, 45, 90 right triangle, so this side right here would be radical 2. If you don't believe me, do your Pythagorean theorem. This is the hypotenuse. So 1 plus 1 is 2. Radical 2 equals x. Okay? So now we know all of our pieces. So now we have to just write our OA's and H's. Okay? So let me get my black back. Here we go. So theta is here. I'm going to burst. So theta is right here. So sine is opposite over hypotenuse. Rationalize this. So it's negative radical 2 over 2. Cosecant, we can just flip that right at the beginning. We were right here. Negative 1 over negative radical 2. So we can just flip that, and we get negative radical 2 over 1, or just negative radical 2. Cosine adjacent over hypotenuse. Sorry, I should have gone black to whatever. Rationalize, and you get the same thing that you did up here. So it's negative radical 2 over 2. I did the same thing that I did up there. Just rationalize. Okay, secant, you flip it, so it's negative radical 2 again. Tangent is opposite over adjacent, or 1, and so in cotangent you flip 1 and you're there. So the 6 answers are negative radical 2 over 2, negative radical 2. Cosine of theta is negative radical 2 over 2. Secant of theta is negative radical 2. Tangent of theta is 1. Cotangent of theta is 1. Okay. Next and final. Woohoo. Okay, standard position. All 6 trig functions. Okay, so we're looking at negative 6, 8. That's up here somewhere. So we draw a triangle. Always drop it down to the x-axis. Oh, you didn't see that. That was bad. Here we go. There we go. That's better. So we went 6 this way and 8 this way. You don't have to put the negative on this. I mean, you can. If you put the negative on, then it's okay. It's all good. Okay, so then we have to figure out this third side because we need to find sine, cosecant, cosine, secant, tangent, and cotangent. Okay, and make sure you have these thetas. Math teachers get very angry when you don't have the theta. The theta is right here, always with the x-axis. So Pythagorean Theorem, or you can remember that it's 6, 8, 10, but it's 6 squared plus 8 squared equals x squared. So it's 60, this is, whatever, 36 plus 64 equals x squared. 100 equals x squared. So x is 10. Okay, and then you should, it says simplest radical form, but that just means simplest form in general. So make sure you simplify. Okay, so I have my 3 sides. I know I'm in quadrant 2, so I know these 2 guys are positive. Everything else is negative. Okay, so then sine is opposite over hypotenuse, or 4 over 5. Flip it, it's 5 over 4. Cosine, adjacent over hypotenuse, 3 over 5. Negative 3 over 5. I lost my negative somewhere. And then secant, flip it, negative 5 over 3. Tangent, 8 over 6, or negative 4 over 3. And flip it, 3 over 4. All right, so I hope everything's right. Good luck.